Let's take a look at section 5.3 on the properties of logarithms. So in the last section, section 5.2, we introduced the logarithm. We talked about the fact that it was the inverse of the exponential function. We looked at some graphs. Now let's look at some properties of logarithms. So the first property we're going to look at is the change of base formula. And this particular formula will allow you to take the logarithm of any number, regardless of the base. Some of our calculators will not do anything other than log base 10 or log base e. If I want to calculate something that's log base 4 or log base 7, a lot of our calculators will not perform that operation. So here is our change of base formula. So if I have log base a of x, and that a is a base that my calculator won't do, log base 7, log base 2, log base 100, whatever, I can take that logarithm and rewrite it as log base b of x over log base b of a. So really, I just put the x on top, this base of a on the bottom, and then log both parts. And that log is going to be a new logarithm, and I'm going to choose that log base b to be either base 10 or base e, one that my calculator will perform. So if I had log base 3 of, let's say, 12, my calculator won't do log base 3. But if I change it to base 10 by taking log base 10 of the x, which part is the x part? Well, it's the 12 divided by log base 10 of the a part, and the a part is 3, that will accurately find log base 3 of 12. I could also choose log base e. So again, suppose I've got log base 3 of 12. Well, to do that on my calculator, I could just do ln of the x part, which in this case is 12, divided by ln of the a part, which in this case is 3. And if I do that on my calculator, ln 12 divided by ln 3, that will give me the value. So let's use it. So use that property. Let's change all three of these using either base 10 or ln to find their values. Work on that, pause it, come back and check your answers. Realize that it doesn't matter if you use ln over ln or log over log, you will get the same answer. So for log base 2 of 32, I did ln of 32 over ln of 2. Divided those out, you should have gotten 5. For log base 5 of 127, I chose to use log base 10. So I did 127 log base 10 of 5 and got 3.009. And then finally, for log base 6 of 95, you can see right here, I did ln of 95 divided by ln 6 and got 2.542. So that's how we can use the change of base to find values of logarithms that our calculator will not perform. Okay, let's look at some other properties. Let's recall the ones that we saw earlier. Remember, the log of 1 is always 0. That means ln of 1 is always 0 as well. Log base a of a is equal to 1. Remember, they cancel out. You're left with the exponent. Ln of e is equal to 1. Log base a of a to the x, those bases match. The answer is x. Ln base e of e to the x, the answer is x. Bases match. And again, these bases match, the answer is x. These bases match, the answer is x. So those are our first set of properties that we looked at with logarithms. Now we'll add a new set to those above. Let's check out the ones on the next page. So here are some other properties of logarithms that allow us to actually do some expanding and contracting of logarithm expressions. First one, if I have the log of two things that are multiplied, u times v, then this property says I can rewrite that as the log of u, which is the first thing, plus the log of v, which is our second argument. So u times v splits up into two logs with an addition, log of the first plus log of the second. It works the same way with ln's. If I had a natural log of u times v, that's the same thing as the natural log of u plus the natural log of v. Suppose I had the log of two quantities divided. I can split those up and call that log base a of the part on the top minus log base a of the part on the bottom. Log base a of u minus log base a of v. And if that was an ln of u divided by v, then I can split those up the same way. ln of the top minus ln of the bottom. ln u minus ln v. So that division splits up into subtraction. Multiplication splits up into addition. And finally, if I have a power, if I have log base a of u to some power n, what I can do is drop that n in front, that exponent, and just call this n times log base a of u. And it's similar if I had an ln, I could drop that n in front, call that an n times ln u. So we'll use these properties in both directions. We'll go from left to right to expand, or sometimes we'll take these guys in the expanded notation and go backwards to condense. And we'll look at some examples on that. Be aware, this is very important, this remark here. There is no property that allows us to rewrite the log of two things that are added or subtracted within that logarithm. So if I had log base a of u plus v, that is not equal to log of u plus the log of v. These properties do not work if you have the log of, and in that argument you have things added or subtracted. Keep that in mind because that's going to be a place where you're going to have a tendency to make a mistake. So let's look at some examples. We'll either expand or condense some log expressions. So let's look at this first one. I've got a log of a 5 times an x cubed times a y. So I've got a log of 3 things that are multiplied. So let's work on this right here. I would like to expand this into several logarithms. And from my properties above, I saw that if I have a log of quantities that are multiplied, I could split those up with addition. So this would become log of base 4 of 5 plus log base 4 of x to the 5th plus log base 4 of y. Doesn't matter how many pieces you have in there multiplied. If I had 6 pieces, I could break it up into 6 logarithms. So I've expanded that using this property rule, this product rule, where if you have a product, you can split them up with addition. Now there's one last step you want to look for, and that is, do I have any exponents that can be brought down in front using that exponent rule right here, that power property. If you have an exponent, you can drop him in front. And what I notice is this spot, I have an exponent, so I can drop him in front of that logarithm. So the log base 4 of 5 stays. I get a 5 log base 4 of x by dropping that 5 in front, and there's nothing I can do with that last logarithm. So that is my result. That is this logarithm expanded into several single logarithms. Let's look at the second one. Got an ln, 7 at the bottom, and I've got a 3x minus 5 that's under a square root, and here's where we have to remember the exponent equivalent of a square root. That's a 1/2. So when I see roots and radicals, I need to convert those roots and radicals to exponents. Now let's work on expanding this into multiple logarithms. So I have the log of two quantities that are divided. And if I have quantities that are divided, I'm going to split those up with subtraction. So I'm going to have the log of the top minus the log of the bottom. So I have the log of the top part minus the log of the bottom part. So I've split up that division with subtraction. Then I'll look over and see, well, are there any exponents that I could bring in front? And I do notice that I have this exponent of 1/2 that I could drop in front of that logarithm. That would give me a 1/2 ln 3x minus 5, period, then minus the ln 7, and there's nothing else I can do with that. I've split this up. I've split this up as much as I could. So always look to see if there's any leftover exponents you can bring in front or any multiplications or divisions you can split up. So that's how we can expand. Now let's look at how we can condense. So now we're going to look at a logarithm in its expanded form. And let's go ahead and work backwards and condense it into a single logarithm. So let's look at A. 1/2 log x plus 3 log of x plus 1. Now, when we're going backwards and we're condensing into a single logarithm, we're going to always look at any coefficients that happen to occur in front of that logarithm. Because those coefficients, if you remember, these coefficients here were originally exponents. So we're going to take any coefficients and bring them back up as an exponent. So your first step is to bring coefficients up as exponents. So this would give me log x to the 1/2 power plus log of x plus 1 to the 3rd power. Always start by bringing those coefficients back up as exponents. Okay, so I took care of those. Now look at what's left. If you're adding, then that means they were originally multiplied. If these guys are subtracted, then that means they were originally divided. But since these two logs are added, that means my arguments were multiplied to begin with. So my last step would be to take these two guys, change it into multiplication. Those two arguments get multiplied, and you're left with, very important, a single logarithm. could leave it like this, or if you wanted to, you could change that x to the 1/2 to the square root of x. Either one of those would be fine. Just check WebAssign to see how they would prefer to have your answer written. So that's how we'll go backwards and change it and condense it into a single logarithm. So let's look at B. 2 ln x plus 2 minus ln x. We'll get started. Look and see if there's any coefficients. This guy has a coefficient of 2, which means he was originally an exponent on this argument right there. So first step is to look for those coefficients. So then I'll have ln x plus 2 squared, bringing that 2 up as an exponent, minus ln x. I don't have any more coefficients, so now I'm going to look at the operation. Here we have a subtraction, so that means they were originally divided. So when I combine those two together, I'll have ln of x plus 2 divided by x. Subtraction means you take the first argument divided by the second argument. And there it is, completely condensed into a single logarithm. Let's look at C. 1/3 brackets log base 2 of x plus log base 2 of x plus 1. Remember, when the base is not written on your logarithm, like part A, it's understood to be base 10. This is log base 10. When you have an ln, it's understood to be log base e. Well, this log is actually written out. It is log base 2. All right, so let's work on condensing this into a single logarithm. Notice the brackets. Those brackets indicate what's in front needs to be distributed inside. So actually that 1/3 distributes to the first log and to the second log. Take that, distribute it inside to each logarithm, and it'll look like this. 1/3 log base 2 of x plus 1/3 log base 2 of x plus 1. So we distributed that 1/3. Now, since that 1/3 is a coefficient, remember those coefficients get put back up as exponents. So that means I have log base 2 of x to the 1/3 plus log base 2 of x plus 1 to the 1/3. Oops, that's a third. So brackets are taken care of. Coefficients are taken care of. The last thing is, let's look at this addition. That means these two arguments were originally multiplied. So I'm going to combine those with multiplication. So I'll have an x to the 1/3. Darn, I keep writing that. X to the 1/3 times x plus 1 to the 1/3. That type of answer is perfectly fine, but we've got to realize when working with WebAssign, it might like a different format. So realize that an alternate way to write this is log base 2. Since they're both 1/3 powers, that means we would have a cube root with both pieces underneath. That's an alternate version to what you see right there. Both of them have a cube root, a 1/3 power. which means they're both under a cube root, so I could combine them into a single logarithm that way. So work on the homework assignment. That's all for this section, just working with those new properties. So let me know if you have any questions.